All right. Good morning, everybody. Welcome to the July 18th, 2025 working group meeting. We'll start off this morning with new members. Looking at our current list, I see Devika from Fuselage Innovations. Devika, would you mind introducing yourself, who you are, and what brings you to the group?
Yeah, sure. And first of all, good morning, everyone. And myself, Devika Chandrasekharan. I just landed in Canada 2 weeks back. Actually, we have a company called Fuselage Innovations. We started our operations in India in 2020. We manufacture drones for agriculture purposes, and we are manufacturing drones for precision using precision farming technologies. We use our drones to farmers, and in India we almost work with more than 10,000 farmers, and we have a product in agriculture in different sectors, and we sold almost 300 plus drones all over India. And here we landed as an international expansion plan, and we are incorporated in TBDC and start doing some projects with Ontario Center of Innovations right now. And that's about a short brief about myself.
Excellent. Thanks so much, and thanks for joining us this
Thank
morning.
you. Thank you.
I also see that Caitlin McGilvery is here today. Caitlin, would you mind introducing yourself to the group?
Sure, thank you. My name is Caitlin McGilvery. I'm a recent grad from the Ontario Agriculture College, and I started with a venture capital firm called Veramito out of Waterloo. So, looking to stay plugged in the ag tech world and learn from lots of cool people.
Excellent. Well, you'll find them here.
Great.
Thanks very much for joining. Um, I believe from our excuse me, from the agenda this week, that's everybody I see. Was there anybody who hasn't, did I miss anyone, or was there anyone who hasn't had the chance to introduce themselves yet who would like to? No? All right, perfect. If that is the case, then we will head over into our presentation from this morning. So this morning we are joined by Jan Butz from Sanctuary AI. And he's here to talk to us, give everybody an introduction to Sanctuary and what they're all about. So Jan, please take it away.
Yeah, thank you very much. Thank you for having me this morning. My plan today is give you an introduction about general purpose robots or also humanoids. Probably it's not the typical application that you're seeing in your working group. I would like to, maybe start some thought processes around about how these robots can be used into the ag tech. So not just in the outdoor areas where it's picking or these kind of tasks, but maybe also for the packaging processes and these kind of or sorting processes. So just to get a broader understanding what kind of use cases are out there and you may be interested in. If you have any questions in between, just let me know, and then I'm happy to answer them immediately. My background is robotics and automation. I've been with Sanctuary nearly a year now. Before, I've spent the last years with the automotive industry in Germany, most of the time being there with BMW in the robotics and automation, or robotic automation innovation area, and now working in the general purpose robots. We're working on, our main focus is artificial intelligence. And the reason why we're working on this is our labor shortage that we are facing as a global, kind of pandemic. So our world's labor shortage right now is around 8.5 trillion in revenues, and that's a deficit of 85 million workers that we will have all across all countries by 2030. And then looking at the robotic and the overall labor market. Right now, the robotics that are out there doing automated labor are only 0.1% of the global labor wage bill. And just seeing that small number is already a huge market that can be, where you can get revenue from. So what are we doing? Sanctuary AI, we are a startup, a robotic startup based in Vancouver. We were founded 2018 and are right now around 125 people, mostly in engineering, half of them software, half of them in the hardware development. And we are focused on three main pillars inside of our company. So our first pillar is our multi-embodiment, the software approach with the artificial intelligence. We're working on one side, on one part is the humanoid we're working on, but also our overall software stack is hardware agnostic, where we're also working with different hardware embodiments. The second part is our dexterity value stream, where we're developing a dexterous hand for robots that can do fine manipulation and other dexterous tasks. The third part is another focus area of us is intellectual property, where we have right now more than 170 patents in the field. And if you take a look at this research that's done by an external firm right now in the robotic startup areas, we are owning more patents than all our competitors combined. What means general purpose labor or general purpose robots? Well, that means a robot that can do multiple different tasks and is not specialized on a specific task. So here, for example, on the top left, you could see the robot doing a sorting task that's fully autonomous. On the top right, it's a precise insertion task, a typical automotive task where you pick something and you place it into a welding fixture. The bottom left, you could see a task where the robot is picking something and then operating measurement equipment for quality assurances. And on the bottom right, it's another automotive task where you handle drive shafts and you're sequencing them for the production line. Now, these are our main areas we're working on right now. So it's the automotive industry where it's a lot of pull coming from for these kind of robots, but we are also expanding into different other industries. I already mentioned we are working on multi-embodiments, and that is one of the reasons there is that we have our ML pipeline, our machine learning pipeline, that is completely hardware agnostic. Now we can run it with off-the-shelf cobots that are out there. We can run it with Phoenix, our humanoid robot, or we can also run it with other embodiments. The benefit of it is that we can use less data for training our foundation models, and we can have early on commercial realization with hardware that is already reliable, that is already vetted by multiple industries, and we are not purely relying on the hardware that we are developing in-house. How can that look? So here you could see on the left side a cobot doing one task. It's a precise insertion task where a gear needs to be placed on a gear shaft. And on the right side, you can see Phoenix, our humanoid system, doing the same task. And on the left side, the engineer messing with the system is for the training process, so that the robot can learn how to deal with variances. So the robot will push to the side, the position of the gear shaft is being moved around. Thereby the robot knows how to handle these different variances that he can see in his real environment when the robot is autonomously doing the task. And the same on the right, where you have Phoenix picking up that gear and also placing it. On the left side, it's trained with reinforcement learning, or it's a reinforcement learning process. On the right side, Phoenix is trained with teleoperation. They have another example in a few slides where you could see how our teleoperation would work. Overall, the benefits of this approach with our multi-embodiment, it's the less data that we would need. So what you can see here, the task on the right was trained in less than 2 hours. And for fully trained, we were able to achieve more than 99% success rates. And this is a huge success for the autonomous learning of systems, because thereby you don't need hundreds of hours of training data to fully autonomous perform such a task. And the robot with this reinforcement learning approach can learn by itself how to do this task, and there's only a supervisor necessary to see if the robot is really doing the task successfully. As already mentioned, the first part on how we're training our robots is usually done with teleoperation. That can be seen here on the left side. You could see a pilot that is wearing some gloves that he can feel what the robot is feeling. So it's a tactile feedback, and he can control the hands of the robot. He's also wearing motion trackers or motion tracking devices where the system can track where his arms and head and shoulders are moving around, that also the robot can do these movements in the same way as the human is doing it. And the pilot is also wearing VR glasses so that he could see what the robot is seeing. Right now, what you could see on the right, it's not the real robot, it's the pilot doing that task in simulation. And then afterwards, he can also do it, he can also do it with the real hardware. And that's usually how we start training our system. So the pilot shows the robot how to do that task. And based on this first training data, then some additional AI learning capabilities come into play, where then the robot can further improve the capabilities that he learned from the human, showing him how to do that task. Our second pillar was the dexterous hands. And there we're working on hydraulic actuated hands. Why hydraulic actuated? It is the power density that we can achieve with it. So most of our competitors are working on tasks that are on hands that are with DC power operated, so electromechanical hands, where you can achieve right now around 100 watts per kilogram. With the human hands, we're around 500. And with our hydraulic hands, we can achieve up to 2000 watts per kilogram in power for our grasps and movements of the fingers. Our main part there is that we were able to miniaturize our valve system. So we are way faster and way smaller and also cost efficient than other valves that are out there from off-the-shelf hydraulic systems. Hydraulic is very often called a dangerous technology if it's around humans or if somebody's working around that system. We are working with, compared to other hydraulic systems, very low pressure. So we're having around 800 PSIs in our system. Already the bike brake is somewhere in that ballpark area. Most of them are currently higher. And with that hydraulic system, we can also ensure that we have an impedance control, so not just position control, so that the robot is also able to react to environments where he only touches something and not seeing the environment. And also for touching, we are working, or we've developed in-house touch sensors tactile sensors, where we can ensure that our system feels the world as we as a human are feeling the world. So the robot should do human-like labor, and therefore we believe that the robot needs to feel the world like a human if he should interact with the world as a human. And here on the left side, you could see how sensitive our fingers of the fingertip that we have developed are. So right now the robot that finger is programmed in a way that it always moves away from the position where the human is touching it. And on the right side, feel free to test it yourself if you have a domino brick at home. Without looking at that domino brick, just trying to touch it and not flipping it over, it's pretty difficult. And thereby you could see how sensitive our system really is. So we're talking about 2 millinewtons that we already can react to, but also for high grasp pressure. So it's pretty wide range. A small overview how these fingertips are then looking at our robotic hand. So here you could see on the left side where the robot is feeling that he's been touched. And what we can do with it is, for example, blind picking. So the robot right now it's under teleoperation. So the operator looks at his left hand and the right hand is picking something out of a container where he's not looking at, it's really just feeling it. And then the system can do precise placings, for example, or as can be seen here, unpacking. That was an example we did with one customer for syringes. But I think everybody knows how difficult it is already for us as a human to unpack these small plastic coverings. And seeing this with a robot is really impressive, and also what kind of tasks are possible then to automate that are right now not able to be automated with classical automation. The other part, how we are learning or how we can train our system with our reinforcement learning approach that I already mentioned, is that on the left side, you could see here a robot hand in simulation learning how to rotate a cylinder in its hand. Then what we were able to do is zero-shot transfer learning from simulation to the real hardware. So that means we trained the whole policy for our system, that how to rotate that cylinder in hand in simulation, and then we transferred it to the real hardware. So a hand that we have in our lab, and that hand was able to rotate the cylinder without any additional learning data. So really only getting simulation data, putting it onto real hardware, and then the system was able to rotate that cylinder. And not just this, the most impressive part is that we were able to take that hand, to hang it upside down, and even putting 500 grams on it, pulling towards the bottom, without that system ever seen it in simulation. And the hand was still able to rotate that object in its hand. An overview how we're currently working with our system. So all the humanoid hardware right now that is out there, even if YouTube tries to make us believe that it's already productorized, most of them are, or nearly all of them are prototypes. So therefore, right now we're working with different customers together on a way to industrialization. So currently we're discovering different use cases with multiple customers. We're working on a proof of technology. Then in the next step, we're trying to replicate these tasks on our side, where we can automate it in our lab area with a proof of technology. Then the next step we're working on with our customers is that we're doing a proof of concept. So we're taking our systems, if that's Phoenix or humanoid robot or other hardware configuration, to our customers and training there the use case and to show them in a 2 or 3 weeks deployment how that task can be fully automated. Then afterwards, after that proof of concept at the customer side, we're working on a pilot. So that's the first system that would be deployed in a customer task, doing fully autonomous labor. And then afterwards, it's a scale-up phase for that hardware and that software that's being trained in the pilot phase on scaling it up to many systems at the customer side. This was a quick overview from my side, but I would be super happy to dive into a discussion about use cases that can be imagined by this group, where the robot maybe could be beneficial for, or where you would say maybe that's something in the future where these systems can be used for. So right now, maybe to start the discussion, our focus is, as I already mentioned, more the indoor-like tasks, the factory-looking tasks. But we've also been talking already to some robot suppliers that were looking to use only our hand with their robots to do fruit picking, for example. So with all this technology, what do you think the automation also in the agriculture areas, agriculture industry could go to?
So I'll start it off. We did have a question in the chat from Giuliano. Are there technical or practical advantages to humanoid robots, or is it primarily aesthetic for the comfort of the humans working beside them?
There are definitely benefits of having the humanoid form factor. So it is the whole world as we're living in is designed for us as a human. So we as humans made the world as it's or designed the world in a beneficial way for us. So if the robot should interact with that world he's in, then the robot, it's easiest for the robot to somehow look like a human. But that's not the only case. Another case is the teleoperation training that I mentioned. So if you want to teleoperate such a system for training, it's the easiest if the pilot don't need to think about how he maybe can control a third arm or a sixth finger. If you can really use the or the pilot can use his fingers, his arms, his upper body in a way that he's used to it, then he could train the robot in an easy way that the robot is able to perform these tasks afterwards.
Awesome.
So the main part about humanoid is 2 arms, 2 hands, and some kind of an external vision system to control these things.
Right. Joe, go ahead.
Great presentation. You asked about the interest in agriculture. We suffer from the same labor issues as manufacturing. So I think that's a yes. There is a market for it. The differences are, you're out in the environment, but that's only in the case of not in greenhouses or other systems. So excellent presentation. Really appreciated it. Thank you.
Excellent. Thanks, Joe. Brian, go ahead.
Thanks, man. Yeah, great. Echoing that great presentation, and it's been fun watching Sanctuary evolve and you guys making more progress. I'm wondering, I don't know if you can answer this. What's the target price point, and what's the business model? Are you guys aiming to sell these as sort of capital assets, so someone can buy it and own it, or is it looking at like a subscription model?
So right now the pricing is still in development. with the customers we're working on. We are aiming in the area, especially in the manufacturing area, that we are around a 2-year return on investment with a 2-shift operation. But we are also aware of that this price would drop further along the line with more and more systems coming up, and more systems being out there and operating. So that's currently the area or the ballpark we're aiming for, because that's from the industry perspective a sweet spot for pricing. And right now, also the pricing structures, there are multiple options right now. So it's either robot as a service, or labor as a service. So the robot is doing that task and you're paying a subscription fee per month, per year, to have that system. Or it can be bought as the overall system. But that's something that is also currently in development. It's most probably a subscription model where you have a kind of an implementation cost or training cost upfront that then distributed to as many systems as you would need. So it's kind of a credit for the first system. You paid for the first system for the development, and then getting kind of credit throughout multiple other systems. Then it's a subscription.
Cool, thanks.
Thanks, Brian. We had a question in the chat. What is the comparison in a subscription cost versus an hourly wage for a human?
On numbers, that's nothing I could tell right now. So compared, but our goal is to have definitely lower cost than a human. And I think for the company purchasing that robot or leasing that robot, it does not make it different.
Are you looking for training partnerships?
What kind of training do you mean? So really the teleoperation part, or I'm not sure from whom this question came. So maybe you can elaborate on it.
Yeah, that was from Clifford. Clifford, would you be able to elaborate a little? Just while we're waiting for Clifford to type that out. Has it been considered to use these robots for military purposes?
It's definitely an ongoing discussion. We are strictly against weaponizing our system. That's also part of our policies that we have. So we have, or there are discussions also with Canadian Armed Forces, but it's definitely not in the weaponizing area. It's then more kind of the logistics that are interesting to automate. But there are, I think, also in the US, many discussions ongoing about weaponizing these systems or putting them into military partnerships. That's something we're strictly against.
Excellent. Graham, go ahead.
Thanks for the presentation. Longtime fanboy of Sanctuary, having known the company for many, many, many years. Curious if you could share some examples in commercial or commercial-like environments where you've seen successes, like really specific. And I know you've been spending a lot of the time in industrial manufacturing and some of the strategic partners that are in your cap table as an example. You've had some interesting relationships. So I wonder if you could talk about maybe some specific examples where you've had aha moments about types of manufacturing, types of assembly, or types of use cases that have been really impactful. So maybe just going a little deeper than what was in the presentation.
Yeah, so very common task we're working on is pick and place. So picking something up with a random bin pick and precisely placing it. So there it's beneficial to have the sense of touch and the AI capabilities of the system being able to react. So if you pick up a sheet metal part, for example, and you need to place it on 2 pins in a welding fixture, as an example. With your sheet metal part, you're covering the pins where you need to place it on. because if you have just two holes in your part, then you need to feel and react precisely to it, where the part should be placed. So that's really one of the beneficial parts of the AI policies, that you are reactive on placing. But another task where you really could see the benefits of the policies, it's if you're dealing with flexible materials. So if you're having a wiring harness that's coming, or you have a wiring harness hanging from a sensor, and you need to plug it in somewhere into a testing device on the final production line. And then you need to detect that connector, even if it's swinging. You need to pick it, rotate it in the right way, and have a precise insertion task. So these are really the benefits that we are seeing right now with that system that you cannot automate in a classical approach. And then also with the hands, being able to tell the system the hand should pick up an egg, and then it's doing it 100 times to pick up an egg without destroying a single egg. But if you tell the system immediately to destroy the egg, okay, that's easy doable, though the forces are there, but it's also sensitive enough to be able to not destroy it if it should not do it.
And I've got maybe a follow-up, if that's okay. And you kind of took it in this direction anyway. I was somewhat involved in helping to connect Sanctuary with this group, and one of the pieces of that was understanding the interest in exploring other commercial pathways. And so part of the thinking is this audience has a unique purview in terms of the potential commercial use cases of robotics in agriculture. And so given that example, right, like mentioning sort of the dexterity, the sensitivity, both the balance between sensitivity and force, I think I'll provoke if there's anyone on the line, because I think part of the dynamic is those who understand the egg sector perhaps better than Sanctuary. Are there use cases where this technology really emerges as saying, like, damn, that would be really impactful, either the training model or the dexterity model? Sorry, to sort of steer in that direction, but definitely there's a really informed audience here to potentially also give that feedback back to Sanctuary about, are there opportunities that this company could be prioritizing potential deployments, not to lead it too far.
Well, just to follow up on that, you've got Brian that's been working on this in cucumbers and tomatoes, and I think I saw Marie on there that's been leading the world on mushrooms. So
yeah, could I jump in, Joe, and ask some questions on that?
Maria,
yeah.
Get you off the bench. Get in there.
Thanks for the yeah. So as far as, let's go, first one is environment.
Maybe introduce yourself real quick, Murray, so he knows who you are.
Murray Good, Mycionics. We're a robot, we're a automated picking service for mushrooms, fresh market, so low damage and precision picking. We are using fingers right now off of a gantry system, but I guess my main questions are, you mentioned that a secondary vision system, like when a human's standing beside the bed, it has to look in and find the mushroom within about 80 centimeters and be able to pick it, locate it, do a manipulation of the mushroom to release it from the bed, and then put it into a destemmer and a packer. Does the robot have its own vision on it, or is there auxiliary needed?
So the robot has its own vision on it. So you could see on the picture right now, the head of Phoenix, our humanoid system. There you could see the camera or multiple camera systems on the top where the robot is using it as a vision. And if you're using our off-the-shelf approach, for example, with classical cobots, where we then have our dexterous sensors on it as well with some grippers, there we have wrist cameras. So at every hand, then there's an additional camera where the robot is where the vision system is close by to the manipulation point, or to the point of manipulation, and thereby it's easy to control the AI system.
Well, that's excellent, because yeah, if we can put it on the hand and be able to fine tune the approach to the mushroom to determine the angle of the mushroom, that would be incredible. So That's a yes. What about harsh environments? Like, can I get a shower, or can you shower it if it gets dirty?
And
Not saying mushrooms will do that. I'm just
yeah,
saying that dust in the field or, things like that.
so right now our focus with the design is indoor, so the manufacturing world. So therefore, right now I would not prefer to give him a shower. But it's definitely also with our off-the-shelf approach where we are hardware agnostic. They can definitely pick a robot arm, for example, that has the full IP rating in combination with an HEV that has that IP rating. And then you can use the same AI algorithms and our dexterous sensors to also give that a chance.
Okay. So and I assume with the AI, you have data collection as far as size of object it picked. Could it weigh an object, like a 40-gram object?
There I would need to talk to our technical team, but I would say out of the box, probably that's a bit difficult because it's low weight and having their precise number would be difficult with our current setup.
Yeah, no, that's fine. As far as we had trolleys that lift them up from ground level to about 12 meters. Sorry, 5 meters. Is it something that they could be bolted on to a lifting device, I assume?
Yeah, that's definitely possible.
Yeah. Okay. All right. Yeah, that's it for now. Very impressive.
Okay. Thank you.
Excellent. Thanks, everyone. So we've got a few more questions in the chat. I see Brian's got his hand up there. So just in the interest of time, I'm going to put a pause on the conversation. I will go through the remaining agenda items we have, and then we'll circle back just to make sure that I've got time to do that, and then everybody can get their questions in. All right. So I'll just quickly go through the rest of this. This week was the ASABE annual international meeting, as well as Ag in Motion in Saskatchewan. Was there anybody who attended those that has some thoughts or comments on how those went? No? All right. Just a reminder, next week we have the Ag Robotics Working Group Demo Day at the Simcoe Research Station. That is on Tuesday, July 22nd. Currently we are at capacity for that event as well. If you are not able to attend that event after all, please go onto Eventbrite and cancel your order so that we have a small waiting list. So that way somebody who currently isn't registered can get in there. So we'd appreciate that if you know you're not able to make it after all. No project updates for this week. For funding announcements and opportunities, there is a seeding digital skills program. CAHRC is working with the Ontario Chamber of Commerce to offer free digital twin training in Ontario agriculture and food employers. Link is there in the agenda if that sounds like something you would be interested in. Okay. Thank you, everybody. That'll bring us to the round table. So we'll head back to
just before we jump there, one other announcement, Dan, Graham Millen's on. They made a big announcement out in Manitoba about the innovation farm. So I don't know if he wants to share that with the group, but now we can do potatoes.
Now we can do potatoes, and everybody loves potatoes. Thanks, Joe. So thanks all. So last week we were in Manitoba for the innovation farms. You guys may know Emily, EMILI. FCC already has an existing relationship with them, a partnership which was focused on supporting the programming for their 5,500-acre broadacre farm about 40 minutes north of Winnipeg. Excited to announce we've expanded that partnership to include a 6,000-acre farm about 2 hours north, which includes 2,600 acres roughly of potato production. And so part of this is the FCC Innovation Farm Network is, a couple of layers. One is expanding the diversity of crop type, soil type, and regional type that we're supporting for the trialing, demonstration, and de-risking of technology. The second piece is increasing the collaboration across the partnership. So obviously many of you guys know Chuck and the Innovation Farms in Southwestern Ontario, very close partners with the Emily team in terms of learnings and understanding different applications. So super excited. That brings the FCC Innovation Farm Network now to over 17,000 acres across 4 partnerships, 6 physical locations, and 4 provinces. So thanks, Joe, for the prompt. Very exciting week.
Excellent. Glad to hear it. Thanks for that update, Graham. Okay, so just going in order of the questions as they appeared in the chat. Back to you, Jan. Can you please give examples of current market applications of these robotic systems or are undergoing trials or scope of use case, particularly in dynamic and harsh operating environments, as in agri-food sector?
So as already mentioned, our focus right now is the automotive industry, but we are expanding into different industries right now. So right now, really, it is automotive, in factory automation we're working on, in body shops, in assembly lines, and on the other side, the logistics areas. That's another task we're expanding into right now. It's pick and place sorting stuff in logistics centers. So really the outdoor and the harsh environment, it's not an area we're currently in, but that's one of the reasons also being into this meeting here today is to see where can we expand to as the next step. And therefore, yeah, your feedback is very welcome to us to see really what is out there, what are requirements that we need to fulfill to get into these sectors, for example.
Gotcha. Excuse me. Are there any cost benefit analysis studies done? And what are the low-hanging use cases which there could be potential demand?
Cost benefit analysis. So not sure what exactly is meant with it. So of course we're doing for every use case we are automating with customers. There's always a question about the return on investment. What kind of cost structures are there? I think that's something, especially in the automotive industry, they're fighting about every cent in their product. So there's definitely these things done. It's not any information that we can share publicly because that's depending on the customer we're working with. And the low-hanging fruit use cases in the automotive industry, that's pick and place, precise pick and place, or precise insertion tasks. What kind of use cases are out there in the agriculture area? That's something you would need to tell me, where you would say that it's maybe somehow comparable with pick and place, or pick a part from a box, place it somewhere precisely, or sorting things.
Gotcha. Brian, I know you had your hand up earlier. Did you still have a question or?
Yeah, but go to Eric's question first.
All right, sounds good. What are the current environmental specifications, mainly ingress protection, operating temperature range?
So right now it's the usual factory setting. So up to 35, 40 degrees Celsius that we have, and indoor, so not with slightly dusty environments. but also they're happy to get your feedback. What are requirements we need to further look into it? Because yeah, I already mentioned that most of the systems are still on prototype stage, so the earlier on requirements are being given to us, the easier we can implement it in the next generations of systems.
Does humidity impact the vision systems in any way?
It's the question about how humid it will be. But these cameras itself, they are getting warm while they're operating, and thereby humidity, it's not an issue we've seen so far.
Excellent. Brian?
Yeah, no, I was just gonna touch on, Joe mentioned that, we at Vineland Research and Innovation Center, so I'm the director of our technology program there, and like Joe mentioned, we're always looking at robotics, and certainly been doing a lot in greenhouse indoor growing. So yeah, definitely potential there. Humidity, of course, is the bigger issue rather than dirt ingress, maybe dripping water and so on. But yeah, those are solvable problems. Um, I would sort of say that, I asked a question about, the business model, the is subscription capital, and Bridget kind of threw out there, like, what's the comparison between subscription costs and wages for humans? Because that's probably going to be the biggest thing. Aside from performance, it's cost, right? ROI. But one of the benefits I think here is that a lot of robotic systems are really good at one thing. And I've been an advocate for that message for a long time. If you really want to make a robot work well, you tailor it for the job. Whereas heading towards these kind of humanoid robots, this anthropomorphic hand and arm configuration, all of a sudden you open that door to multi-purpose, which is going to be really game changing if we can make it work. And it's great to see the the touch, the tactile sensing aspect, and like you mentioned, Jan, the sort of the compliance of the hydraulics. These are all sort of making a lot of us nod along, like, good, okay. Because Tim, you asked about handling soft fruit, so yes, that kind of thing is possible there, right? But yeah, one thing that I've heard from some greenhouse growers who are, they're watching this kind of space, and they love the idea of getting a humanoid robot. A big thing for them is like crunch time, when you need that extra pair of hands to fill in a certain task, and that could change, the next month. So not as much of a question as a comment, but and I'll reach out, Jan, to you or others at Sanctuary. But yeah, in that sort of in this space of agriculture in general, the ability to get a system like this on the farm and teach it new things, the way that you can teach a worker, a laborer, to handle new tasks and different tasks, without having to reconfigure the robot, just sort of retraining. And that, like you showed, that sort of AI enabled reinforcement learning, sort of lower amount of training data is awesome. So thanks. I see your email in there, Jan. So I'll touch base.
Yeah, happy to have additional discussions afterwards. Yeah, just to add on to it, maybe also with the training part. So right now it is really, you've seen the suit our pilot is wearing with all the gloves and all that equipment that is necessary. But that's also something that's improving right now. So with the universal robots, for example, that we are training, also we're using the Meta Quest system. So you're wearing VR goggles, you're having just two handheld controllers, getting a bit of feedback, so you're not feeling as much as wearing these gloves, but having different options there as well. And also that technology gets cheaper, that gets better. And then it is also the goal from us that everybody can train their own policies. So you can get these systems, you can tailor operate them, and then train them how to do your task.
Oh, sorry. No, okay. Joe, go ahead.
Yeah, Jan, agriculture can be a difficult sector to penetrate in just because we're rural. It's very specialized, but we want to make sure, we onboard or integrate in organizations like yours. Is there anything, do you have a specific ask from this group? Brian's trying to engage. How can we support you? How can we support your success? Anything or any ideas on, what you need and how we can help?
So it's really the kind of use cases where you would say these robots or these capabilities our hands have, our system has, can be a benefit and would make sense to automate these things, because I think we are all facing that labor shortage, especially in the next years coming up. So all these things where you would say, yeah, maybe that's an interesting task. Maybe we cannot accommodate a system there today, but maybe in 5 years.
Sure.
So the sooner we have an overview about what is out there, what are the requests that we're getting from your side, the better we can plan for it. And then I think it's also kind of grown capability throughout the next years with onboarding these technologies, that it really that we can ensure that it will survive in these harsh environments.
Just one last question. How fast can they run? And if they're not legally documented farm workers, can they outrun the ICE folks in the US?
Right now we are focused on
Sorry.
on an HEV base, so not walking, because that's way more stable and you can have way more batteries with you. And that driving, I think by norm or by robotic norms, you're not allowed to be faster than 2.5 meters a second.
I was just teasing.
Yeah.
I see the US is a mess right now, and there's all kinds of unpicked vegetables because Donald doesn't like immigrants.
Yeah.
But you did make me wonder, Joe, and I was going to ask this. I'll just squeeze it in. Jan, is the general aim to have the system operating like at the same speed as a human, or potentially can it do tasks faster? Like, can you teach it to mimic the motions, but then basically times 2, times 4 on the actual speed?
Yeah, it depends on humans are impressive good in learning tasks at impressive speeds. And then what we definitely already have in our repertoire is that we can speed up policies afterwards.
Cool.
So if you can train them in teleoperation and then you can speed them up afterwards.
Yeah.
But right now the systems are still slower than a human. But they're getting faster with every use case we're working on, with more data we're getting. And that's definitely improving, that we're catching up to the human speed, and then hopefully also sooner than later are improving the speed of the task compared to a human doing that task.
I get picked on sometimes. Is my cucumber harvesting robot faster than a human, or even as fast as a human? And I always say it doesn't matter. It's the ROI that matters, because if the robot cost $100, it could take an hour to pick one fruit and you still have a great payback. So it's tricky, right? To compare.
It's really about how fast it can pick, how long it can operate.
Mm-hmm.
So there's no breaks necessary. It can work day and night, so no sleep or no necessary, not multiple shifts. So there really depends on what is the application, how fast it needs to be done. And also you don't need to be as fast as a human sometimes, because then you have some days off in between again, especially in the picking areas. So have a constant system working on that would keep your maintenance lower, because it's not operating as max speed or max payloads, and then it has a longer lifetime. So it's always a trade-off of all these different parameters.
Mm-hmm, mm-hmm.
I actually have one quick question. You mentioned batteries earlier. Are these uh are these running on batteries right now? And how long can one of these robots operate on a single charge?
For us, it depends on the embodiment that we're using. With the next system that is currently under design, we are aiming for an 8-hour runtime with one charge.
Perfect.
And then some quick charging in between so that you all the time give it a quick charging burst in between, that the overall runtime is unlimited. Not that the system needs to stop for 3 hours at a time. So it's better to have maybe then 10 minutes times in between to charge up the system again, instead of running for 8 hours and then having 3 hours breaks.
Right.
Especially in the automotive industry, you have some tasks that are stationary. So where the system is doing a mobile task, where he needs to drive around, and then he goes to one station and doing a task there for 5 minutes. And that time while the robot is doing that task can be used to give him a 5-minute charging time while he's doing that task.
Gotcha. All right. That is bringing us to time on the meeting for this week. Jan, I'd like to say thank you very much for taking the time to present to us today and to answer all these questions. I think it's safe to say everybody was very interested in everything you had to say. So yeah, thanks so much for being here.
Yeah, thank you for having me. And if you have any questions, I posted my email address in the chat. Feel free to reach out. I'm happy to engage in further discussions.
Excellent. Thanks so much.
Thank you.
Everybody else, thanks so much for joining us for another great week. I hope everybody has themselves a great weekend, and we will see you all here next Friday.
Thank you.
Thanks, man.
All right. Take care, everybody.
Bye-bye.
Bye.